Let's dig in a little deeper. As with any model formula, we can interpret the model coefficients. Since 0.06 is simply the slope of this log odds model, we can interpret this to mean that for every 1 percentage point increase in humidity, the log odds of rain are expected to increase by about 0.06 on average. But since this log odds scale is relatively confusing, this coefficient interpretation isn't very meaningful. We can also transform this coefficient to the more meaningful odds scale by taking e to our coefficient, or roughly 1.064. Now we have to be a little more careful with how we interpret this coefficient. Since this odds model is not linear, we can't interpret 1.064 to be a slope or a fixed amount by which odds increases when we increase humidity by 1. In fact, we see that the increase in odds is slow when the humidity is low, and it gets more rapid as humidity increases. With this in mind, the coefficient on the odds scale tells us about the multiplicative change in odds when we increase humidity by 1. Specifically, for each 1 percentage point increase in humidity, the odds of rain multiply by 1.064. Or another way to think about this, we can say that the odds increase by 6.4%. Now, a change of 1 percentage point in humidity isn't very noticeable to the human body, so let's think about this on a more meaningful scale. On a scale of 10 percentage point increase in humidity. In this case, we can see that when we multiply our coefficient by 10, that we expect the log odds of rain to increase by 0.62 for every 10 percentage point increase in humidity. Similarly, we expect the odds of rain to multiply by 1.887, or that is, for every 10 percentage point increase in humidity, we expect the odds to increase by 87%, or to nearly double. For example, the odds of rain when there is 100% humidity are nearly double the odds of rain when there's 90% humidity. Unfortunately, given the complexity of the probability curve, which is again S-shaped when we zoom out, it's not easy to interpret the model coefficients on the probability scale. Beta 0, or 0.06 in this case, is neither a slope or a percentage change.